Hey guys, what's up? Welcome back to my video, and today we're going to be doing a build video for my AUX FPV Acrolite 230, and we've got quite a few cool electronics here, so let me just run through them quick. Obviously we have the AUX FPV frame, and I did do a separate review on this guy. You can see I did now switch to 20mm standoff, so it weighs about 102 grams, which is really nice. And I also printed out the GoPro mount for that there, which only weighs 15 grams, and that just sits up front. I'm going to be using the Foxeer micro arrow right here, really nice cam. I'm going to be using the FreeSky X4R SB, and you might be wondering why I'm using this versus something like the RXSR. I've actually been having a few issues lately, and with just different things while racing with having random failsafes, so I've been switching to X4Rs just to test stuff. As so far, this is the only receiver that I've never had a single failsafe with, so I'm just running that. For the flight controller, we have the Betaflight F4, so it's their newest flight controller. You can see it has an OSD chip right there. And on the other side, where is it? Right there, we have the current sensor. Really cool board. However, just because of the way the pads are, some of them are on the top, some of them are on the bottom, especially for the ESC and battery connections. That's probably going to be a real pain to solder, so I'm going to have to probably solder upside down with the ESCs going out, and then flip it over and finish it like that. And it'll probably be a pain to work on, but we'll see how it goes. And for the ESCs, using the Betaflight BL Heli 32-bit 35 amp ESCs. These are also really cool, but they're once again pretty big and large and heavy. And if we look over here, we do have the LED on there, and they are kind of thick. They're not really that even, so they're going to take up a lot of space on the arm. But they do give you the BL Heli 32 goodness and all that telemetry data and stuff if you wire that up, so that'll be interesting to see how it goes. For the VTX, I'll just be using a TBS Unify HV Race with the white noise mounting board that'll just stick on there. And then the UFL will just run out the back, and then I'll just be using a TBS Triumph on the back to stick out there. Nothing special. And then for the motors, we have the brand new T-Motor F40 Pro V2, which are 2306 2400 kV right there. And I've already done a separate review video on these, so there will be a link down in the description, but really excited to try these motors out. This should be a really nice build, so let's get right into it. Okay, so first up, I would normally start mounting the motors. However, due to using the Betaflight F4 with some of the pads and things underneath, it's going to be a little bit more tricky. I'm going to have to think ahead on this build. And because of the way that the stack screws are shared with the arm screws here, I'm going to have to use these little vibration isolating standoffs. But because I'm also, there's a lot of buts here, I'm using the shorter standoffs. I don't have a ton of room to play with since I'm using this extra board. So what I'm going to do is actually put the VTX on first, mount this guy just on top of here. That's going to sit like that. And then these will screw on there, and then the flight controller will be able to sit up there, and I'll still have plenty of room to clear. And then I'll wire up the Unify with smart audio. Yay, I'm finally using smart audio to the flight controller, so I don't need access to the buttons. So first up, we have to get the Unify prepped and installed onto this mounting board. Okay, and to do that, we do need to solder some things to it, so just go ahead and clip off the heat shrink that's already on the Unify here. Just clip it off, be careful not to hit any of the components. Expose that, there we go. So if we take a look at the white noise board, you can see this side says for your receiver, but I'm not going to be using that. I'm going to mount it in the back, sticking here, just so it'll be more open and it'll leave more room in the stack. And then this side is where the Unify mounts to. So if you see these little pads over here on the corners, that's where we're going to be soldering to. They match up on the Unify. If you look there, these little gold contacts will match up right there, and it'll solder in place to hold it down, and then you just run your wires out through there. Okay, so this guy's just gonna go like this. I'll do this side here first, just make sure I have it all lined up. Okay, there we go. Just zoom out so you can take a look at this here. So I just connected the pads there. Just bridge them together with a little bit of solder on the corners. Make sure nothing is shorting out over here. And you should be good to go there now. That's mounted really solidly on there, and of course make sure it goes on the right way. There is big pads underneath the UFL connection, and there's big pads on the board here, and you don't solder them together, just make sure those line up the right way, and should be all set for that. Okay, and I'm just going to run it with the UFL pointing forward, so that way I can pull it back along the VTX here, so when the antenna mounts, it'll be able to zip tie to the top plate. Inside here, I don't want the SMA sticking out, I want only the coax sticking out, and then I'll be able to bend up right there, so it's going to be really nice. So I'm just going to leave the SMA connection off while I mount this, so it's just going to push right onto the board. And there we go, that's mounted down nice and low, and the antenna should be able to just pop on like that and stick out the back. So there we go. And then obviously you can put just a little bit of a kink in it to get it to rise up to the height we want, but it's only 20mm standoff, so it doesn't have to go very high, so it's going to be really nice and clean, and the flight controller will sit just above it here. So now we can put these rubber standoffs on these screws and come with the frame that go through the arms and now into the VTX mounting plate, and this way it'll give us enough separation for our flight controller, and it'll be soft mounted as well. Okay, so just putting the arrow forward so we have no issues. Fits on real nice, and you can see that it does clear the stack just fine, so we're good to go there. So if we look at the flight controller itself, the positive and negative pads for the ESCs are actually underneath here, while the signal, ground, and telemetry pads for the BL32 data is actually on the top. So that's going to be pretty annoying. So to actually mount this, I'm going to flip it upside down and solder on all the ESCs first, just like this, solder them on, and then I'm going to flip the whole thing over and put it back down, and then I'm going to put on the motors, so that'll be easiest. However, if you do break something and have to work on this, that'll probably be a real pain in the butt. Okay, so I'm just going to start by tinning the flight controller and the ESCs. So they give you a 16 gauge wire with the ESCs to connect from the ESC to the flight controller. However, we're not going to be pulling nearly enough current for that to matter, especially with how short of length of the cable it is here. It's going to be like 1 inch long. We definitely don't need 16 gauge wire for that. So I'm going to be using 18 gauge in between the ESC and the flight controller, and all I have is blue, but that works fine since everything else on here is blue. But first I'm going to get all this tinned up. Let's just start with the ESC here. And now these are relatively thick boards, a lot of metal in them, so you're going to need a decent bit of heat and sort of let them get heated up before you start applying the solder. And these main input pads are just absolutely giant. I don't know why they are so big. I'm not even going to tin the whole thing, you don't really need to. Just adds more weight and solder. Signal up front here. And also we need to get the telemetry pad up here, which is these three little ones over here. The SWC pad, it's called. It's a really tiny one. And it's really annoying how it's all the way in the back here to get that Betaflight, the 32-bit telemetry data, and it's not up front with the signal. Now let's do the flight controller, and the Betaflight boards are known for being really hard to tin, but that's because they have a PDB in them, so there's a lot of material to heat up, so you're going to need a lot of heat, and you're going to have to apply it over a while before everything starts getting heated up, because it's probably going to suck it out to other parts of the board, especially on the ground pads. You're going to need to apply a lot of heat. And of course, once you get the board initially heated up, mainly the grounds, everything will start to become easier. Onto the ESC pad side. And you can see I saved this side for last because now that I did the other side, the board is already preheated, and hopefully you can tell everything is just flowing really nice. Just applying a little bit extra heat to the pads before I put the solder on, and it's tinning up really well. No issues here. There we go. Okay, so jumping ahead, you can see I've finished off the first two ESCs, and the reason I did these first without showing you what I was doing is just to make sure I knew what I was doing, so I didn't make too many mistakes on camera. So basically it's just the power out, the signal and ground out, and then the little red wire goes to the little pad for the 32-bit telemetry data. So let me do one for you here. So I'm just going to take this off. You can see I just left this loose for right now. And these two ESCs come out the front, but these ones come out the side, so be aware of that. So you get it started, just take one of the ESCs and just set it here on the arm where we're going to be going to. And then the pads come out the side here. So I'm pretty much just going to leave it on there and sort of line up. Let's see, the outer one is negative. Line up where it's going to need to go. Obviously, leave a little bit of extra slack here. Just push this down. Leave some extra slack, and I'm just cutting them relatively close to what they need to be. And once again, this is 18 gauge wire. It comes with 16 gauge, but that's too big, for my opinion, to use. So this one's going to need to come across. To right here about, so I'll cut that. There we go. So now we have our two wires, and obviously we just need to strip and tin these guys. And if you can, try doing your tinning away from the other electronics so that any of these splatter does not come back and cause a short. So just be a decent distance away. Let's get these guys tinned up. Right there. Okay, then we can just take the flight controller off and solder them on, and because the positive wire does have to cross over, I made that one just a little bit longer, so that way I know which one is which right here. Here. Make sure you get a good connection, and then it flows down all the way through with the pad, just like that. And of course the ground is going to be a little bit harder due to needing to heat up more of the board. So here goes the ground. Takes just a little bit longer, but works just fine there. And you can see two pretty nice solder joints there. So now I'm going to put the controller back on and bend this guy down, bend this one over under it actually, make it a little bit cleaner. This is really why I'm not a fan of separate ESCs. It just adds so much extra weight and hassle, and it does not look clean. So I'm just going to put a standoff on to keep the flight controller down. So this one here is positive, and it looks like I did cut them a little bit too long, but that's not a big deal. You can just snip them right here. It's better than cutting them too short. Then I like to take the stack back off here just so we can have easier access to it without everything being crinkled up, so we can just solder it straight here. So positive on this guy, just gonna bend it over right here, set something on the ESC so it stays down. just gonna connect it up. There we go, that's a really nice joint there. Then we can do the negative. Push the wires into position here. There we go, it's not too bad. And then I can size up for the signal and ground. And now the ESCs do come with this wire. It is 20 gauge, and what I've been doing is just cutting it in half right here and using this for the signal and ground. And these are on top of the flight controller here, the pads, so it's going to be way easier to just sort of stick these guys on there. Just like that, without having to do any other flippy floppy with the flight controller. So we can hold these down. So this guy is the ground. That's going to come right here. Just going to mark it a little bit with the cutters. And then the signal is going to come right here. And again, leave extra slack so you don't have to extend anything in case you cut it too short. Okay, there's that. So now all we have to do is solder these ends up to the ESCs. And luckily the pads are of a decent size, decent space apart. So it's nothing too hard to solder to. Right there's the signal, and this will be the ground. Right there. Then lastly, I'm going to run the wire for the Betaflight 32 telemetry, so that's just in between the signal and ground and the FC here, and I'm just using a random tiny silicone wire. So that's just going to have to come down here in between them, just like that, and run out here to the tiny little pad on the end called SWC on the ESC. And I'm not sure why they put it over there. It should be right at the end with the signal. Seems like a big afterthought if you ask me. Here goes the data wire on the RX1 pad. I'm gonna need something to hold this down. Make sure it sits all the way down against the pad. Just like that. Okay, so there's that. Let's just get a close-up of it so you can see it better. It's just this little SWC pad. It's the middle one of this row of 3 here. That just comes up to the middle pad on the flight controller, RX1. So that's just going to sit in there. Now, because I have a Mac computer and not Windows, there's no configurator for the Betaflight 32 ESCs. So I actually can't access any of these settings on this, like the current limiting and such, because if you look, there is a little individual current sensor on here, so that's quite cool. And there's other data like RPM, temperature, and active current limiting, all this cool stuff, but I can't access it because I don't have a Windows computer, because there's only a configurator available for that. So I'm actually leaving, if you noticed, the wire connections bare on the end here with the heat shrink, because I'm just going to have to swap the motor wires to change a direction, because I can't do that in the software either. So just putting a piece of heat shrink over the connections here and just shrinking it down. Okay, and there we go. Then that ESC, I'm just going to put you can see the capacitors sort of make one end sit and one end not, so I'm going to put under just this part right here, I'm going to put some double-sided sticky tape, stick that to the arm, and then put a zip tie around it. So that's 3 of them, and then we can put the motors on, and actually a lot of the work after that will be done. We just have to add the receiver and camera, and then connect those wires up. So let me put the other ESC on. Okay, so there we go. I got the ESCs all finished up, as well as I just installed an XT60 lead, and I did use 16 gauge wire here since it is just 1 inch long. You don't really need anything more, especially not 12 gauge. 14 or 16 will do just fine. You can see I soldered it up to the positive and negative pads underneath there. It's an interesting way to do it, but I'm not really a fan of it. However, if you do leave it all separate like this before you strap everything down, it's not that big of an issue to deal with. So before I actually attach the ESCs to the arms and put the motors on, which I'm going to be doing last, I'm going to leave that off so I can just have easy access to the VTX under here, so that I can attach the wires for the VTX and the camera, as well as the smart audio cable. We can just get those sorted out before we strap everything down. So the 5V, I'm going to be running the 5V and ground from the UniFi out into the camera here. I'm not going to be using VBAT because I don't need the OSD from the camera here, as I will have the OSD from the flight controller. So something I'm not used to is having an actual OSD. As well as I'm going to be running the smart audio from the VTX up to the flight controller so I can have VTX control. So for right now, I'm actually going to just install the camera because it's so far away. It won't be hard to maneuver the wires while it's mounted. So I'm actually going to do most of this off camera, as it's nothing interesting. I'm just going to be connecting the video to video, the 5V to the red on here, and the ground to the ground on the camera. And then I'll just get the length for the smart audio cable to go up to the flight controller, so nothing interesting. Okay, so I went ahead and connected the camera up to the VTX, and actually forgot, since this is one of my very few builds that does use an onboard OSD, you do have to run the camera and video transmitter through the flight controller, obviously, to utilize the OSD. So the camera goes to V in and the VTX goes to the V out there for video. And I just connected the 5V and ground from the UniFi up to the camera then. And then I connected the input from the UniFi right here to the, I tacked them onto the main battery pads there, so that'll get full voltage. It's getting kind of a mess in here, but luckily that gets closed out of the way. You can't really see it too much when you put it down. And then I ran the white wire, the audio from the VTX up to TX1 for our smart audio control there. So that just kind of tucks away. Actually does not look too bad once you close it all up there. So next I'm going to be installing the receiver, and I'm going to be putting it in the back here like this. Just going to stick it down to the back plate and sit it there, so the wires are just going to run to the flight controller, and I already have them tinned. It's kind of hard to see. I should have made these wires longer. I didn't leave myself enough slack, so hopefully you do. But these 3 pins, we just have the S-bus 5V and ground to power that. Really simple. And then we'll be adding our motors. Alright, so we got the receiver here, and on these front 3 pads, it just goes S-bus 5V and ground there. So just got 3 spare silicon wires. Okay, there we go, that's that. I'm just going to twist the wires up a little bit closer to it right there. Now I can get the heat shrink and just cut out a big piece. And this stuff is 3/4 inch heat shrink. And I'm just going to run the wires, the antennas, back around. I'm just going to kind of hold everything in place while I start to get it shrunk down. It's a thick heat shrink, so it's going to take a little bit more heat and time. And there we go. Still have access to the bind button right here, as well as we can see the LEDs, and that'll make it more manageable for the antennas, as now they're a much shorter length, which will be nicer to stick in the frame. So let's wire this guy up. Actually, I'm going to stick it down. Actually, no, I'm going to wire it up first before I stick it down. So the wires, flip the flight control back around. I really should have made some of these wires longer. Did not leave myself enough slack to flip this back upside down. So for these guys, they're going to have to come over here. And this time I definitely am going to leave enough slack right there. Probably should have did the receiver earlier on, as these would have been easier to access, these through holes. There's one. Two. And lastly, the ground. Three right there. Just sort of bend those over a little bit. Flip this guy back down, push the wires under, twist this up, and we are good. So we definitely do have some decent slack there, and I can actually push most of that underneath so it looks cleaner and gets out of the way. So now I think we're actually pretty much done. I think we are done for the electronics. Let's see, what else am I missing? All we're missing is the motors here, so I'm going to go ahead and secure the ESCs down with the sticky tape and zip tie like I mentioned before. I'll put some nuts on the flight controller as well as sticky tape under the receiver so that everything's sort of held down and out of the way. As well as then we can put the top plate on, and I made the pigtail here just long enough so that it can curve out the side right here, and then it'll zip tie to the top plate just like this. It'll zip tie around the standoff there, so we should be good for that. So yeah, let me do that off camera. Okay, here we are just about finished with tidying up. You can see for the ESCs just the zip tie and the sticky tape there. Then for the VTX antenna, I just ran 3 zip ties, strapping at the top plate, sticky tape down the receiver, and I'm just showing you the last antenna, how I mount it right here. This works really well for me on a freestyle quad where I might want to do a little bit longer range, like up to a mile of flying. So I just take the antenna, I'm just going to put it up through a hole in the top plate here, which will be the slot right here that I put the zip tie to, and I did use nice big thick zip ties here, so they're going to be stiffer and a little bit more durable. I'm just going to run the antenna up through that slot right there, and then it's going to come around to the zip tie, and I run it on the inner side so that if it does bend down and get hit by the prop, it's less likely that it's going to chop the element of the antenna. So it might just hit the zip tie instead. So I just take some heat shrink, some thinner stuff at first, and put it on to the zip tie here. So there we go, just slide that down. And this antenna is staying nicely in put, so then it's just a matter of heat shrinking it here. Just going to push the base around towards the front, and I'm going to hit the back. Okay, I'm just going to give it a slight bend outwards as it begins to cool. Chop off the excess zip tie. Make sure you leave a little extra room just in case so you don't chop off the tip of your antenna. That would hurt the performance. I'm going to take a bigger piece of heat shrink, and this stuff just needs to be stretched out just a little bit, so I do it with some pliers. That way I like it to cover the base of the zip tie as well. You can see this one does not, this one does. So I just put the bigger heat shrink on, and that just makes it stiffer overall and just keeps it from moving around too much. Makes it a little bit cleaner as well. So I'm just going to do the base of it first. Move my way up. Try and give it just a little bit of an outward bend to get the separation angle between the two a little bit further away for better polarization. It's not absolutely perfect, but it is a decent bit away from the VTX. Nice and tall, a little bit of an angle there. You'll get really good reception with a setup like that. So now lastly, we have to move on to mounting the motors. Everything else is fully done. It's kind of funny because if you watch any of my other build videos, I always start with the motors first, but just due to the nature of the flight control in this build, I had to do it this way. But this last step will be really simple, so let's do it. Okay, so I have my Loctite, and the screws that T-Motor gives you are 7mm long, which is really nice. They do use a 2.5mm hex head there, so be aware of that. Just put a little bit of blue Loctite on the screw. This is just some stuff I got from Hobby King a long time ago. It's lasted me 2 years so far. So we do have a decent amount of length between the wires and the ESC here, about 1 inch. So I'm actually going to bolt them on first. I don't need the extra flexibility of not having the motor bolted on when we solder the wires. They're long enough to be able to maneuver. So I'm gonna mount with all 4 screws, and I'm not going to be soft mounting them. Flight controller soft mounted, and I just really don't feel a need for it. Okay, so there's the first 2 screws in, and there is something interesting about the bottom of this arm. Let's see if I can show it on a different one. They're not slots cut all the way through flat. You can see they're almost like 2 circles cut through. So you can either put the screw in the outer circle or the inner circle, which is 16 or 19mm spacing. So since these motors are 16 by 16, you have to use the inner part for both of them. Otherwise it won't fit. So just make sure you are aware of that. And of course the set screw has plenty of clearance in between the cutout on the arm there, so no worries about it rubbing. So I'm just putting the last screw in there. Since I'm using all 4, it'll line up right in the middle. I can start tightening them down. Since these motors use 7mm of screw there, you're going to have a decent bit of thread. Actually, there should be some coming out of the top of the motor. So you can go pretty tight on these, but of course you're threading into 2mm of aluminum, so you don't want to go crazy. If you're using 4 screws in Loctite, there's no chance they're going to come out. You can see these screws come to just, you probably can't see it there, but the screw comes right to the top of the base, which is exactly what you want. I'm really happy they included 7mm screws here. And then of course you also do get the spare set screw and little washer for that. Let me put the prop nut on so I don't lose it. Right there. So of course now we have to solder the motor wires to the ESC here. So that is just as simple as going 1-to-1 straight up, because you can change the direction in the software on your computer, but because I have a Mac and the software is not available for it yet, I'm going to have to manually swap. But I don't remember which way goes which for swapping, so for right now I'm just going to wire them all straight and I'll be able to change it later. So for these, people like to tend to leave a little bit of slack here, but it is better in case something shifts around, but I just don't really like to. I like the way it looks nice and straight and clean, so I just don't really leave any slack here. And I did leave slack up the ESC, so I could pull it down a little bit if I needed to. So that should be all right there. I shouldn't get in trouble with not having enough slack. Go ahead and ruin the motor, cut off these nice pretty wires that are good for a 4-in-1 ESC. So there we go. So yeah, with this wire I did just cut it just a little bit too short, so I'm actually gonna shorten the other ones just a tiny bit. And that way I can just go like this and pull the ESC closer. Whoop, out of shot. Pull the ESC closer just a little bit, and then I should be fine there. So let's strip and tin these guys. So just make sure the wire goes all the way down against the pad right there. Sinks down nice and well. Hold it for a second to let it cool. You'll be golden. There we go. Perfect joints there. Those are really nice. Just gonna push the wires in just a little bit to make it a little bit cleaner, and then push the ESC back up just a tad so that it takes out the extra slack. So that's nice being able to move this just a little bit there. So there is that motor all mounted. So let me do the other 3 and we'll finish up. Alright, so here we are back, and the quad is 100% all finished up. See, the motors just look absolutely fantastic out here. Definitely am not a fan of using separate ESCs. I'm just so used to 4-in-1s now, it just looks so much less clean like this, but you know, it's still a relatively clean build overall, and it came together really well. And the biggest thing will be how it performs in the air, and this should be a really, really nice performing build, so the way separate ESCs looks isn't going to matter in the air. So let's get right to the weight. I'm going to guess the weight. I have not weighed this yet. We do have light motors. Actually, let me put some props on real quick. Just to, because usually, you know, a dry weight when I guess is with props, because that's how you fly, isn't it? Cyclone V2 on here. They're what I ran on my last freestyle quad. They're pretty nice propellers. Might run different props on this, but I probably will end up running these again. They're just really nice, all around, well balanced freestyle props. Okay, got the props on, so let's guess the weight. So these are decently medium heavy props. We have light motors, we have heavy separate ESCs, a light camera, heavy antenna, light frame. I'm gonna guess 321.21 and see where we come out with that. So 340, whoa, I was off. I thought it was lighter than that. Unfortunately, using these separate ESCs like this definitely does add quite a bit of weight. Not just separate ESCs, but also these ESCs in specific. They're very heavy and large. If I did swap to a 4-in-1, I bet I'd save at least 20 grams there. So 340, that's not terrible. Still probably lighter than a lot of people's quads, but for me, I was really hoping somewhere under 320, so I can get the all-up weight under 600 when I have a battery and a GoPro on there. And if I add more stuff, like I'm going to put the foam on there for the battery, as well as the battery strap, that comes to 344 right there, and then the GoPro mount. Oops, the GoPro mount will just go up front. That's 360 grams. So it definitely is a little bit heavier than I like, and I might swap these ESCs out, but depending on the performance, I might leave it. Have to see how it flies. Alright, and so for the fateful plug-in test, see if anything smokes. I did check with the multimeter, nothing says it's shorting, as well as I do have this little smoke stopper from Race Day Quads. So let's plug that guy in and see what happens. And these props are fully loose, so you know, even if a motor did spin up, it would not be a problem. Otherwise, I would have taken them off. So let's just plug this in. Everything looks good. Oh, what the? That motor just spun for a second there. Interesting. Well, hopefully you can see when I did plug it in, the lights on the ESCs light up real quick. Just a quick little blip. So that's kind of cool to have the RGB LED on the ESC. However, I'd rather just have a 4-in-1, which is a lot lighter, rather than have little LEDs there. So yeah, that's the end of the video. That was the AUX FPV Acrolite 230 build using the T-Motor F40 V2 2306 2400 kV, Betaflight F4 flight controller, the Betaflight 32-bit 35A ESCs, Foxeer Micro, FreeSky X4R SB, and a TBS HV Unified Pro Race. So there will be links down below to all the parts in the description, as well as there will be a link to the little smoke stopper from Race Day Quads, and there will also be links to the motors and frame. I did a specific review on both of those. There will be links in the description, so check that out. Please subscribe, and I'll see you in the next video. Bye.